ground sampling distance, GSD, is a conversion from pixels to Euclidean distance. So how GSD works is we have some variables that we need to know. The sensor of the camera. So this is where all the light is projected into this sensor. We need to know the width and height of the sensor. Then we need to know how far away is the lens on the camera. We call this the focal length. And then we need to know how high above the ground is our drone or our camera in this case. We use this ground sampling distance to convert from pixels to Euclidean distance, and in our case, it converts it to a 2D plane, so it projects everything down to a 2D plane called ground. So we can go up to the image up here. We're converting 3 pixels in this image we can see here in this example. Then by calculating the ground sampling distance, we convert pixels. So 1 pixel is equal to X amount of centimeters or meters in whatever case you have. So we're using this formula to calculate or compute the ground sampling distance for the height of the image and the width. So we know for each pixels in the height and for each pixels in the width, what kind of conversion we need. So they made a sample here, converting from a very big camera. And in their example there, for each pixels, they are 2.36 centimeters. So you can just multiply your GSD to the length in pixels to calculate the Euclidean distance. In our case here in the algorithm, we can also use this because we already know the distance in pixels, the shortest distance in pixels from ship to any kind of solid objects. Let's see if we can find an example here. We have a very short line going from the left side of the ship onto the boat. Then we know from point A down on the ship to the point B on the dock. We have let's see here, if I just pause it, we have a distance of this many pixels. This is a square distance, so you have to square to take the root of it to get the actual pixel distance. But we can then use the GSD to convert this number to actually Euclidean distance. And as I told, we are projecting things down on a 2D plane, so we're expecting things to be the same height in the image. So the main advantage is very precise if you're using high quality pixels or high quality images, because the more pixels you have in your image, the more precise each calculation will be, and conversion will be a lot better in this case. So this is also why we choose to use ground sampling distance